Welcome to NASA's Jet Propulsion Laboratory. I'm here today to interview astrobiologist Conrad. I'm Zoe Bentley, and this is Exogeology ROCKS. And this is Conrad. So, tell us a little bit about what you do.
Okay. Well, I do have the best job in the entire world, and that means I get to look at the world and think about what we can learn on the Earth that might be useful to understanding the other planets. And the other thing that's really cool about that is in trying to understand how the Earth might relate to places like, say, Mars, we can figure out what it is about all the materials that make up the Earth that allow there to be life here, and ask ourselves the question, do we have those same materials and that same environment on any other planet? And if we do, might we also have life there?
Okay. So how did you get interested in astrobiology?
Astrobiology is kind of a late thing that happened in my life. I've always been interested in a lot of things, and I took a long time trying to figure out whether or not I wanted to do one thing or another. And when I started studying science, I really started because I loved crystals and minerals and rocks. And one day I thought it would be really interesting to understand the relationship between all that rocky stuff and everything else on the Earth. And why does some stuff end up in a rock and some stuff end up somewhere else? And so they had just invented this term geobiology in the college curriculum. I'd already been to college and studied other things. And I asked, could I get this PhD in geobiology? And they said, sure, but you'll have to study fossils, and maybe you could study human origins. And I thought, gag me with a spoon, I don't want to do that. So I just studied about the rocks and the crystals and their physical properties and what their chemistry is like. And then just right around the time I was finishing, it was like a miracle, all of a sudden astrobiology started becoming really big. So I called a man who had just come to JPL and started a group to study astrobiology. And I said, I'm desperate to come do this. Would you hire me? And so he was in town, Washington, D.C., which is where I lived at the time. And he came and he interviewed me. And I was just on my way to a bicycle ride, so I was all dressed up in my bike clothes. And I go in for this job interview. And he says, oh, you're a bicyclist? I said, yeah. I said, I'm also a musician. He said, you are? I'm a musician too. So we kind of hit it off as friends, and then we talked about the different kinds of science we both wanted to do, and he gave me a job, and instant astrobiologist.
So what are you currently working on? What's your current project?
I'm working on a lot of things, but my two favorite things I'll tell you about. The first thing is I'm working on this Mars mission, which you might have heard of. It's called the Mars Science Laboratory, and it will launch next year, late. And I work on an instrument called SAM. SAM-I-AM. Actually, SAM is an acronym. It stands for Sample Analysis at Mars. And this instrument is really cool. It's a trio of three things. And when the Mars rover picks up a rock and grinds it up and sticks it into us, we can measure the gases that come off of it when we heat it, and then we can measure what the chemistry of the rock is, and if there are any molecules part of that rock that, maybe from life or maybe from some other reason, we could measure an organic molecule. So basically we're going to Mars to prospect for these organic molecules.
Okay.
And the second cool thing I'm doing is I'm studying what things about environments in the Earth make it habitable for life. It's kind of like real estate assessment for animals, plants, and everything other than just humans, and try to figure out what about the physical features of the environment, like is there a big slope to it, are there a lot of rocks, is it grassy, things like that. What those features might tell us about why living things live there or don't live there. And then I do a backwards thing from environmental assessment. Instead of looking at that environment to see what's wrong with it and what might be, say, polluted or something, I look at it to see what's right about it and why living things might want to be there.
Okay. So, what's a typical day like?
Oh, a typical day starts very early. I get up at 4:30 because my dog will start requesting breakfast. I guess you wanted the science part, right?
You can tell me all of it.
Okay.
It's kind of funny about the dog. The cats do that too.
Yeah, because when they're hungry, they're hungry. So my dog wakes me up. I get up at 4:30, have breakfast. Then I like to live near where the mountains are, so I take a long drive. I get to the lab, try to be here by about 7 or 7:30, and then I answer a bazillion emails, and then I start thinking about what do I have to do to organize my mission activities, and what do I have to do to organize my science activities. And sometimes we are lucky we get to go out in the field and make measurements. In that case, we get together all of our gear, we test everything, we pack it up, and then we head out. Sometimes I go to Death Valley, like I did last month. Other days, we do experiments in the lab. We look at samples that we've collected in the field and we make measurements. We try to find out what the minerals are. We try to find out what the chemicals are that are in the minerals. Then we try to find out what else is in or on a rock. It could be living cells, it could be organic molecules, but every rock tells us a story about what's out there, so some part of every day I'm thinking about that story.
Okay. What are some examples of projects that you've worked on before?
Let's see, projects I've worked on before include going to Antarctica twice, trying to understand rocks that live inside, organisms that live inside the rocks. There's no other animals where I go, just these little microbes. There's no plants, there's no animals, there's no bugs, there's nothing.
That's in Antarctica?
Yes, it's an area called the dry valleys. And because there are no predators and the conditions are kind of cold, it's just microbes living inside the rocks. So went there to study how those organisms live in the rocks. Also, I've been to the Arctic 7 times, study the same thing there, and also measure the things about habitability I told you about. Sometimes I go to the local California deserts, and then I've also been to the bottom of the sea a couple of times to understand what those organisms are that live at the deep sea vents.
Okay. Yes, I heard that you were in a movie called Aliens of the Deep. What was that like? Was it like being in a movie and going to the ocean floor? Tell me about that.
Well, it was really cool. It's a little bit scary going to the bottom of the sea because you're in basically a big ball. And actually, it's not such a big ball. It's about 6 feet across. So there you are. The pilot of the submarine is basically on his knees, and then there's a movie director, and we're all squished in this little space, and it takes a long time to get to the ocean floor, so it's a couple of hours down there, and then of course you're down there exploring, and then it's a couple hours back. So here you are in this ball with the crushing forces of all the ocean and the fires of hell spewing up through hydrothermal vents. And the main thing that I'm worried about is, will I have to pee inside this submarine in front of a famous movie director? And the answer is I made sure I didn't, but it was very stressful. And the thing that's really neat is there are viewports. They're only about this big, and they're very thick walled so that the ocean doesn't collapse. So you can either look directly through the viewport at the sites on the ocean floor, or you can look at the monitor from the IMAX camera where he was filming. And that was pretty cool because you could see details. And the other thing that was neat about being in the bottom of the sea was we had a science instrument there that we used to see if we could measure the detection of organic molecules in any particular way. Not just are they there or are they not, but can we measure them? And that was pretty neat.